recording. If it's not fine for you, please let me know. I'm now recording the session so that later I will upload it to ODTÜ class, and then maybe you can have a look at some specific parts. First, I want to go through the course policy. The syllabus is already available on ODTÜ class once again, and this presentation is also available. But I want to go over it here with you, and then if you have questions, please raise your hands, and then, or you may write your questions to the chat area so that I can read and try to answer your questions. So as I mentioned, this is the first lecture of 533. This is content design course. And we jump to the second slide. As you know, my name is Washaman. Right now, these days, it's not important, but I have these offices and my phone number, but I prefer to use email. So if you have any specific questions, you can directly send me an email. And as you know, once again, we will have lectures on Tuesday and Thursday mornings. On Tuesdays, we have 2 lectures starting at 9:40, and then we have another one at 10:40. And on Thursdays, we have a single lecture, and links are actually the WebEx links right now is available on class, so you can just click on these links and open the WebEx software and start watching the lecture. And if actually the university switches to Zoom, then I will prepare new links and let you know about these new links. And we will have another hour. Actually, this is called as coffee hour, or you may call it as question and answer hour. Starting this week, tomorrow, for instance, you'll have some chats in the morning once again at 10:40 this time. I checked most of the schedules of graduate students, and this should be actually a perfect time slot for all of you. I don't think any of you have lectures, but if you are taking different courses from various departments, you may have conflicts, but not a problem. Since it's just a coffee hour, we will talk about various things, and probably we'll be talking mostly in Turkish. And if you have some questions about the course, about the policy, about projects, homeworks, quizzes, but I don't have any homeworks. But I will not be recording the copy art obviously. I will just record the lectures only and then upload them to class. We have 2 course websites. The course material, the grades will always be on ODTÜ class. The lecture notes, the videos will always be here. And we have another one. This is a Piazza page. Right now, I didn't open my account here, but you can easily have one and post your questions there. It's a website for questions and answers. Another important thing is that I don't need to actually answer all of them. If you know the answer of your friend's question, then you can type it, and then later if I check that it's correct, I will mark it as a good answer, and if the question is a good one, I will also mark it as a good question. And depending on your performance on Piazza, I may give you some extra credits at the end of the semester. So make sure that you use Piazza efficiently. You may ask questions about the projects, about some specific topics. So it's a kind of a forum, Q&A platform. So feel free to write any questions. So this is a catalog description. This is available on the catalog of our university. And we will be going through all these topics. I don't want to actually read them one by one. We'll go through them in the weekly schedule. So this is our weekly schedule. As you see here, is tentative, so it's might be changed, but most probably we will have no change. We may have some little changes maybe around depending on our pace. We cannot finish some of the topics Then I may remove one topic and try to cover the important ones. This is the first week. As you see, we are kind of doing an introduction, and you have an assignment I will talk about later. You need to do a kind of Python course, finish a Python course. Platform is not matter. You can find any tutorial online and try to finish all of them. And then in the second week, or maybe on Thursday, we may start discussing the proofs, the mathematical proofs, since they will be important in the rest of the semester. So we need to learn the fundamentals of proofs, how we can prove a given algorithm, given equation. So we will spend some time on the proofs, mostly in the second week. And in the second week, I will assign your first mini project, and as you see, there are 5 mini projects. They're not homework, a bit harder than homeworks, and they will have programming tasks. Actually, most of them have programming tasks, so you should have strong programming skills, otherwise you may have problem in this course. And then in the third week, you'll start discussing some data structures. Actually, I will focus more on the data structures of Python, since we'll mostly be using Python language in this course. So our main focus will be on the Python data structure. But you will have just a single week on data structure. This is a very broad topic, actually. In computer science department or computer engineering department, there are even courses, maybe 1 or 2 courses on just data structure. So it's just a kind of introduction to data structures, and you will learn all of these while doing these mini projects. And in the fourth week, we will focus on analysis of algorithms. Since our lecture depends on many algorithms in CAD, in computer-aided design, we have many algorithms, and in the fourth week, we will learn how to analyze these algorithms. Which one is better in terms of time, let's say, or which one is better in terms of memory. Since we are using computer, we have limited sources, limited memory, and we have limited power. So that's why we need to somehow evaluate the algorithms and then decide which one is better and other one is worse. And to the end of the fourth week, we'll focus on some 3 data structures. It's a kind of continuation of the third week. It's a special one, and in computer design, it really helps. So we need to know the fundamentals of trees. Then in the fifth week, actually, you'll start going into details of CAD. You may assume that 3 weeks are kind of review of computer science. And starting from the fifth week, we will discuss the fundamentals of computer design software. But obviously, this course is not a drawing course. I'm not going to teach you NX or another software, since some people are asking which software are you going to learn. But this is not a drawing course. You should have learned it in your first year. And that fifth week, we will be discussing some types of representations in CAD systems. How we are going to represent models by using their surfaces or solids, or just using wires, or using triangles, meshes, or just pixels, or different kind of things. We will go into details, have some knowledge on line segment intersections, how we are going to determine the intersection of lines if you have many of them on the plane. And you will see that in a very short time, you can determine all the intersections, even there are maybe thousands of lines on the plane. Then on the sixth week, we will discuss a specific problem by using linear programming. Our main focus will be on solving the casting problem. I will show you an image later. It's a bit special algorithm. You don't need to just use it for casting, but you can use it for many different purposes. And then in the seventh week, we will focus on the curves. There are different types of curves. These are the basic ones. And we will learn how these splines are formed. And in the 8th week and the 9th week, our focus will be on the division of the surfaces or planes or 3D volumes. We'll focus on Voronoi diagrams first and then Delaunay triangulation. They are somewhat related to each other, so we'll cover them consecutively. And then in the 10th week, you'll be going into the details of CAM, computer-aided manufacturing. As you see, we will just spend a week on these topics, so it's a kind of an introduction. Not cover all the details, but you will have just a basic notion, and then maybe you may have a project about it and go into the details of process planning and path planning kind of things. And then in the 11th page, we'll discuss the convex hulls, given some number of points, how you determine the convex hull of these set of points. This will be the main problem. And if you have time, we will focus on some specific data structure, geometrical data structures. And then to the end of the semester, we will focus on topology optimization. We'll go into details of some specific algorithms. We'll discuss the advantages. We will play with some parameters of the algorithms, and I may give you a project. I don't know what. We can discuss it later. And in the last week of the semester, we will be going through some algorithms for robot motion planning. And let me come to the slides. Yes, this is important, as I mentioned. This is actually prerequisite for the graduate students. If you're a graduate student, this is the only requirement. If you believe that you have strong programming skills, you can take this course. But if you are an undergraduate student, you have another requirement. I'm not written here, but you shouldn't have any courses remaining from your first, second, and third years. So you should just have courses remaining from your senior year. Otherwise, you cannot take this course. In the last years, some students actually took this course while they have second or third year courses, and they had real difficulties. So that's why this semester I don't want any undergraduate students having third year courses. So if you're undergraduate students and just have fourth year courses left, then you can take this course. And this is the textbook, but you will be, let me say, maybe about 7 weeks. You'll be using this textbook for about 7 weeks. This is a computational geometry textbook, and it's a very popular one. I think there are also PDF versions available online you may purchase. But as I mentioned, you'll just use it for about 7 weeks, not for the complete semester. We have other reference books, for instance, in the beginning of the semester, maybe for about 3-4 weeks, you'll be using this one. They're nice examples. The discussions are really good, so I will be mainly using this textbook. And you have further reference books. There are many of them about the fundamentals of design software systems, CAM software. So if you are interested, you can have a look at these reference books. Now the maybe the most important slide, the grading part. So let me go through one by one. You'll have many projects. You also have seen in the outline, you have 5 of them, and they will be about the topics covered in the previous weeks, and mostly include, as you see here, programming tests. So this is a very important issue. You should have high programming skills, and you should have completed the Python assignment. Otherwise, you're not able to get much points from this deliverable. And then, starting this semester, in the previous semester, I didn't have quizzes in the lectures, but I think that this will be useful since I'm not going to have any midterm. Quizzes will be kind of midterm for your grading, and depending on the topic, we have 1 or 2 pop quizzes, and at the end of the semester, I will drop just one of them. The lowest one will be dropped while grading your quizzes. And then you'll have a final project. This will be a bit more difficult than the mini project. This will be a comprehensive project, and you'll do some extra literature survey, more programming tasks. So it will be correspond to 30% of your overall grade. Then you'll have a final exam, but I'm not going to have a written final exam. You'll have 1-by-1 oral examination, and you'll be responsible for all topics you cover in the semester, and it's just 10% of your overall grades. And lastly, depending on your performance during the lectures, on Piazza, or on your overall performance in the course, I may give you 5%, up to 5% extra points. If you have questions right now, I think it might be the best point. If you have questions, you can unmute yourself and ask your question. No questions? Or I think you cannot unmute yourself. I'm not sure. I don't remember the settings, but let me unmute all of you. Okay. Any questions, guys? So that means there is no question. Okay, then I'm continuing with the rest of the slides. So what happens if you miss the deadline of a project? You can still submit it, and I will collect all the projects through ODTÜ class. You will have some Turnitin assignments there, write your report, and sometimes you will actually also upload your programming files, some Python files or different files. I will have different sections for each type of file on ODTÜ class. And if you are late, let's say for 1 day, then you will have 10% deduction, but you can only do it for 5 days. You can be late up to 5 days, and if you are late more than 5 days, then I will not accept your project, whether it's mini project or final project. So what about the quizzes? You may sometimes miss the quizzes if the reason is just due to your medical excuses. You should send your report to me, and then you can be exempt from these quizzes, but it shouldn't be more than 2. Can be maximum be exempt from 2 of them. If it's more than 2, then you'll have a makeup examination for you regarding these quizzes, and probably we will do it at the end of the semester. What about the exam policy, missed exam policy? As I said, this will be an oral examination. It's quite difficult to miss it. We can arrange a specific time slots for you in the morning, in the evening, and we can have your final exam. But if you have again, medical excuses, you can solve it with a makeup examination. And this is about disabled accommodation. If you have any problems, any psychological, physiological problems, you can send me an email and I will try to find a solution for your specific needs. It's an important issue. Please make sure that you read this honor code of our university by taking this course. Actually, you say that these are fine for you and you accept this honor code. So these were some illustrations from the topics. Let me jump to the second week. Actually, I have gone through it in the outline, but you may have more details here. In the second week, it was about proofs, different types of proofs. And then in the third week, we'll be discussing the data structures. As you see, we have a data structure, a stack data structure. Fourth week, we'll be analyzing the algorithms, some trees, binary trees, different types of trees. The fifth week, we will discuss the representation of geometric models and then do some work on the line segment intersection algorithm. And in the fifth week, we will be discussing linear algorithm, linear programming, and our main focus will be on this casting problem. Given a kind of a solid, this will be given, for instance, and you'll say that whether this one is castable with a single mold, which means that if it's castable with a single mold, then you should be moving it in Z direction. It's a difficult part, and that means you cannot cast it with a single mold. You need to have at least two of them, and we can easily determine it with a linear programming approach. Seventh week will be about the curves, different types of parametric curves. And in the eighth week, we will be discussing Voronoi diagrams, then Voronoi triangulations. The black one, actually, the red ones are, here you see, are the Voronoi diagram, and the black ones are lines of the Voronoi triangulation. So they are highly related to each other. We'll discuss how to draw them manually and with using some computer software. 10th week is about, as I said, CAM, complete manufacturing. You'll focus on process planning of additive and subtractive type of manufacturing operations. And in the 11th week, we'll discuss first the convex hulls. If you have time remaining, then we focus on like such geometric data structures. In the 11th and 13th weeks, our focus will be on topology optimization. If you have such a box, let's say, and depending on your loads and initial conditions, you'll try to optimize this given part in order to have less material and in order to have more compliance. The last week, they will work on some algorithms for robot motion planning. As you see, this is our starting point, and this is our final point, how we can reach to that point once you have such obstacles in the environment. So let me show you some example projects from previous years. This was the mini project one in spring 2017, and it's about using specific data structures, and they form such geometrical models by using such just a string. The details are here, you can have a look at it. So here you see you have a string into your function, and then you form a tree from the string, and then use that tree to form such a geometrical model, such a 2.5D. This is just an extruded model of this sketch. So we have the 2D structure, and then it's extruded in Z direction, and you have that 2.5D CAD model. And this is just done with the help of a string. Don't need to write or develop anything in a CAD software. Without CAD software, actually, you're able to obtain such CAD models. And then the second main project, we have many questions about algorithms, about the fundamentals of computer science. You see some proof, some questions about analysis of algorithms, some questions on intersections. This might be the easiest mini project. And It's an example of a 30-minute project in spring 2017. It's about Voronoi diagrams, and since we're supposed to use actually Grasshopper and Rhino software, sometimes they have written specific scripts, Python scripts into their Grasshopper software. The aim is here, a 3D CAD model is given, and then you need to convert it into a wireframe, and on the outer surface you just have Voronoi diagrams. And in the fourth one, somehow similar to the previous one, the difference is that this time is 3D. Actually, previous one is also 3D, but the interior is empty. In the interior of these parts are empty, but in the fourth project, they used a bit different version of the previous problem and had internal Voronoi edges in the objects. And in the final project they actually worked on a topology optimization. They used some available plugins, and this is actually the summary of the project. You have a mechanical part with some initial conditions, some load, and then do the optimization, obtain the densities of each finite element, and then generate a specific element for each specific geometric shape for each density, and then obtain the final shape. So this was an automated version, and if you simply change the load or change anything in the shape, you can directly have this final geometrical model. Then we had actually conference papers. These two guys actually did great, and we have written a paper about it. You can have a look at the details if you are interested. And here are the new projects of fall 2017. And the first project is this time it's about Euler cycles, about kind of path planning. This is kind of a path composed of Voronoi diagrams, and your aim is to find a continuous path from this to the given set of edges. And then we had another paper, another conference paper using conference paper is outcome of the new project one, presented it in Ireland last year. And then the second one was the same as the previous second mini project, so I don't want to go over it again. This is the third mini project of fall 2018. It's about incline slicing, about additive manufacturing, about physics position modeling. There are such specific 3D printers where they have inclined printing option, and try to actually develop a kind of CAD software for these type of printers. And in the fourth project of fall 2018, we had an optimization problem. In additive manufacturing, we don't want to actually use any support structures for most of the time. So in this problem, our aim was to use kind of an optimization tool of Grasshopper, which is called Galapagos. And students use this tool to determine the best orientation for the given shape. Obviously, this is the best orientation, for instance, but this might be if you're not aware of, if you don't use an optimization tool, you cannot obtain this one. Manually, for a simple shape, yes, you can easily obtain, but once the part actually gets complicated, then you may not decide on the best orientation yourself. So you need to use such specific tool. Then in the final project, it was about a simulation of a specific hybrid system. Use a commercial product Pocket NC, and we assumed that there is another additional tool on the Pocket NC, so that additional tool is performing additive manufacturing, and the available tool is responsible for CNC machining. And students try to do a simulation about it, and most of them actually have done good jobs. So this is the last year, 2019. The first project is somehow similar to the previous ones, but this time the strings, the types of strings are different. Use similar approach. I've given them some strings and then they convert it to such 3D shapes. And the second one, again, this was the same, so I jumped to the third one. It's about linear programming. The problem actually I mentioned in the outline. This time they implemented the problem in Grasshopper and tried to let us know whether the given any polygon, any polyhedra is castable or not. Fourth one is about Voronoi tessellation, but this time get a specific problem. You may read the details here. As you see in this bunny example, there are, I think, about 50 cells here. And the problem is that we are pouring water, let's say, from a specific hole at the ear of the bunny, and then this water actually should go into all the cells. But the thing is that there can only be one hole, two holes in each cell. This is the main requirement. I'm sorry, one hole for each cell, not two. Maybe you just have two holes in the first one, but for the rest of the cells, you can only have one opening, and this was a different problem, and students were able to come up with a solution. The fifth project was about, again, Voronoi diagrams and convex hulls. I think the Voronoi diagram was about a proof, a mathematical proof, and the convex hull, again, kind of a mathematical thing. So they didn't use any Grasshopper or different software. They just use Python programming and try to come up with a specific algorithm. And the final project was about incline slicing, but this time I combined two mini projects together. What you are going to do is here is that you have a shape and you first determine the orientation of the shape and the orientation of the slicing plane. So once you have these optimum plane and the optimum part orientation, then you are done, and you'll have also you'll need to do some shell generation, some infill paths generation. So this is about printing, but the main difficulty was in terms of determining the optimum slicing plane and optimum part orientation. So let me briefly go through your assignments. If you are going to take this course, then you should complete a Python tutorial. There are two examples here, and you should prove me that you have finished one of these tutorials. Or if you have already taken some Python courses from different, let's say, platforms, it's also fine. You can just send me your certificate or kind of a screenshot, then you're fine, and you don't need to do an extra one. And other thing is that the deadline is the 5th of October, 2 weeks later, I think. And this will be 10% of your first mini project grade. And I will have a specific part on ODTÜ class so that you can easily upload your screenshot or certificate into that assignment. I think these are all I can say. Now I can unmute all of you, and if you have questions, we can start discussing. Any questions, guys? Any questions, guys?
Can I ask a question?
Sure.
Can I ask a question?
Sure.
Can we use external when Can we use external assignments?
So,
Doing our
what's your name? By the way, what's your name?
Yiğit Ergenç.
What's your name? By the way, what is your name?
Yiğit Ergenç.
Okay, let me find you, and then the rest of you. Okay, let me find. Yes, Yiğit, go ahead, please. Can you ask it once again?
Yes. Can we use external libraries when writing scripts on Python?
Depending on the project, I will let you know. Sometimes I don't want you to use third-party libraries, but sometimes if the problem is difficult and if our main focus is a different thing, then I may let you use. But if our main focus is the library you are looking for, then I will not let you use such libraries.
Yes. Okay. Thank you.
Welcome. Any other questions, guys? You can also write. I don't know if I forgot the settings, but can you write? Yes, I think there are some chats. So the question is, can we answer the pop-up quizzes using mobile phones? Yes, probably you can easily do it. There might be multiple choice type of questions and some little explanations or some matching type of questions. So you can, I think, do it with your mobile phones. So if you have questions, you can also write it into chat area, or you can. I don't know whether you can raise your hands or not. I don't want to unmute all of you since there's a kind of echo and I cannot hear your questions. Let me show you the ODTÜ class platform here. This is the announcement part, and as you see, we have the links for all lectures. They are the same for the rest of the semester. I'm not going to have a new one for Tuesday lectures. You can just click on it and open the WebEx platform and start watching the lecture. And we have the syllabus here. So this is kind of summary of the presentation I just made. Summary. And there's a link to the Piazza page. And this is the course policy I just gone through. So, and I will also upload this recording probably to here underneath week 1. And starting Thursday, today I will start discussing the first topic. And it will be about mathematical things, about the fundamentals of computer science. Any questions, guys? If you don't have questions, we can call today. Let me unmute all of you once again, but please tell you're going to ask a question. So there's a question about what do you mean by that? What do you mean by that? It's a website, so you just need to. It's a website, so you just need to. Tutorial. Connect and then do the tutorial. So I think it's better you write questions on the chat area. So this is it. Let me click on it. So you can just simply start the tutorial. But I don't know whether this is updated or it should be updated one. So if you download this PDF document, you should have the links. For the other one, it should be the same. It's the second level, I think this should be free. But if you want to improve your skills, then you may also take the Python 3 course. Might be, I think, not free. You pay some money. But this is fine for us, so you can go through this tutorial and prove me that you have finished this tutorial till the end of second week, and you'll have 10% of your first mini project. Any other questions, guys? So let me the most important issue. If you're an undergraduate student and have courses from third year, second, or the first year, you cannot take 533. But if you have just courses remaining from your fourth year, from your last year, you can take this course. So I will wait for some seconds. Then if you don't have questions, you can call today and
Hocam, can you hear me?
Yeah, which Python version will we use? We'll be using most probably 3.5. But I have also planned to use an online platform of Google Colab. You may not need to actually download some Python libraries, Python engine actually into your computer. You can directly develop your projects on the browser. No questions, guys? And tomorrow it's, I think, 10:40, we will have coffee hour. So you can ask any question in that coffee hour. Here, another one. Can we use the Python from versus code? I couldn't get your question. Can we use the Python from?
Hocam Visual Studio galiba arkadaş.
Okay, Visual. Yes, you can do that. You can use Visual Studio, but I prefer to use PyCharm. This is a very nice one. Let me show you the one actually I'm using. But as I said, I will test this. I plan to use an online platform. So yes, I think you see the PyCharm. This is the one actually I love to use. Right now it's Python 3.7, but 3.5 should also be fine. I love the environment of PyCharm, and it's again a free software. So other questions, guys? If you don't have any, then you can meet if you are available. You have a copy and talk about the course, about anything you like on Wednesday tomorrow at 10:40. And the link is, as I said, the link is here. You can simply click this link and join our copy hour. Lastly, unmute all of you and then say goodbye. Okay. Have a nice day, guys. Tomorrow or Thursday. This is the first lecture of mobile. Enjoy this course, and but you will enjoy this course, and you need to work. The thing is, there are lots of projects, and you need to spend some time projects, and you need to spend some time on programming. Okay. Have a nice day. Bye bye.
İyi günler hocam.
Bye.